All right, so in today's class, we are going to cover the topic of indefinite integrals. Indefinite integrals are those integrals that do not have limits, upper limit and a lower limit with the integration sign. So when you integrate them, you add a constant of integration. Those functions, those integrals are known as indefinite integrals. Now, if you have any function, let's say in the form of x to the power of n. So for example, if you have x to the power of 4 and you need to integrate this, then the integration of x to the power of 4 is going to be you raise the power of the expression by 1. So 4 plus 1, 5, divided by the new power 4 plus 1, that is 5, plus a constant of integration. So integration of x to the power 4 of dx, this was the indefinite integral and you integrated it. Now, when you have a function, let's say x square plus 3, and let's say it is being times by 5. If you have this expression and you are being asked to integrate it, again, it's an indefinite integral because the limits are not associated with it. So whenever you have a scalar number being multiplied, you can take the scalar number outside the integral sign. For example, like this 5 times integration of x square plus 3 dx. Now you can integrate the function. I'm referring x square plus 3 as a function. So I can integrate this x square plus 3s x cube upon 3 plus 3x plus c. Is this clear?
Yeah, sir.
If you have two functions being added or subtracted together, then and you are being asked to find the integration of the sum or the difference of the function, it is the same as saying integration of the functions individually. For example, integration of 2x square plus 5x dx is same as integration of 2x square first and then integration of 5x. So 2x cube upon 3 plus 5x square upon 2, and then you can add a constant of integration at the end. Are the three rules clear?
Yes, sir.
Okay, then let's try this example. In the first part, you are being asked to integrate the product of x squared times this function 10x squared minus 8x plus 3. So to simplify your working, you're going to multiply x squared with all the terms, all the individual terms. So x squared being multiplied by 10x squared is going to be 10x to the power of 4. X squared times minus 8x is going to be minus 8x cubed plus 3 times x squared is going to be 3x squared. And then you integrate it individually. So integration of 10x to the power of 4 is going to be 10x to the power of 5 upon 5 minus 8x to the power of 4 upon 4 plus 3x cubed upon 3 plus a constant of integration. And as a final step, you can simplify this 2x to the power of 5 minus 2x to the power of 4 plus x cubed plus 3. Is this clear?
Yeah, sir.
Okay. Try the next one.
Okay.
For the next one, what you have been given a fraction, so you can uh, make the you can write it like this and then integrate. You can split the fraction up x to the power of 4 times x over root x minus 2 upon x over root x dx. Now you can try from here.
Okay.
All right. So to solve this, you need to solve the denominator first. X to the power of 1 times x to the power of half is x to the power of 3 over 2. 3 over 2 plus 2x to the power of 2 times x to the power of 3 is 3x. 3 times x square is 6 plus 2 is 8. 8 times x cube is 16. 16 times x plus 2 is 24. 24 times x plus 3 is 36. 36 times x plus 2 is 48. minus 2 upon x to the power of 3 upon 2. If you simplify the numerator and the denominator, you're going to get x to the power of half, sorry, 4 minus 1.5 is 2.5 minus 2x to the power of minus 3 upon 2 dx. With me so far?
Yeah, sir.
Okay. Then if you are going to integrate this, x to the power of 5 upon 2 is going to be integrated as x to the power of 7 upon 2 divided by 7 upon 2 minus 2x to the power of minus 3 upon 2 plus 1 is minus 1 upon 2 divided by minus 1 over 2 plus 3. To simplify this, you are going to get 2 upon 7x to the power of 7 upon 2 plus 4x to the power of minus 1 upon 2 plus 3. Are you
Okay.
getting the same result?
I got a different one, but I probably did a calculation error.
Okay. Let me know when you're done. We are going to move on.
Okay. Sir, I've copied it.
All right. Few more examples. Find each of the following integration of x plus 2 times x plus 5 dx. Now, the two expressions are being multiplied. So, before integrating, you must multiply them to get a simplified expression. So, if you
Okay.
multiply x with x plus 5, you are going to get x squared plus 5x plus 2 times x plus 5 is going to be 2x plus 10, which is x squared plus 7x plus 10, and the integration is going to be x cubed upon 3 plus 7x squared upon 2 plus 10x plus 3,
Yes.
right?
Yeah.
Similarly, for the next one, if you multiply the two brackets out, you're going to get 2x squared plus 3x minus 2x minus 3, 2x squared plus x minus 3 dx. Integration is going to be 2x cubed upon 3 plus x squared upon 2 minus 3x plus 3. Okay?
Yeah, sir.
How do you plan on doing the third part, x minus 5, the whole thing square?
You can use the identity to simplify it.
Yes, you are going to use the identity to simplify this. This is going to be x squared minus 10x plus 25, and then you can simply integrate it. X cubed upon 3 minus 10 x squared upon 2 plus 25x plus 3. And then whatever is being simplified, you can simplify further. Yeah.
Okay.
Okay. Part D. What is the first step that comes to your mind?
So you can like separate and write 4x square upon x minus 3 under root x upon x.
Very good. 4x squared upon 2 minus 3x to the power of minus half plus 1 is going to be half divided by half plus c. Why are we adding plus c every time? Because it's an indefinite integral.
Okay.
2x squared minus 6x to the power of half plus c. Now for part E, the denominator has x cubed times x to the power of half. So 3 plus zero point 0.5 is 3.5, which is 7 upon 2. So
Okay.
x to the power of 7 upon 2. Now I
Sir,
can,
Belger's rank, could I just answer it quickly?
sorry, come again?
No, I'm saying the Belger's rank, could I just answer it quickly?
Yeah, yeah, sure, sure, sure. I'm
Okay,
going,
thank
going
you.
to wait.
Okay.
Now x to the power 5 divided by x to the power 7 upon 2 is 5 minus 7 over 2, that is 3 over 2, plus 5x to the power of minus 7 upon 2. Now you can integrate this. X to the power of 3 upon 2 plus 1 is 5 upon 2 divided by 5 over 2 plus 5x to the power of minus 7 upon 2 plus 1 is going to be minus 5 by 2 divided by the new power of 5 by 2, negative 5 by 2 plus 3. So this is going to be 2x to the power of 5 upon 2 upon 5 minus 10 upon 5, that is 2 plus 3. This should be your answer.
Okay.
Okay. Okay, now we are going to see integration of functions of the form ax plus b to the power of n. If we have an expression that is encapsulated in brackets and raised to some power, we are going to see how the integration of such function is found out. So whenever you have an expression that is encapsulated in the bracket and raised to some power,
Okay.
the integration is like this. You write the expression in the bracket and raise the power of the bracket by 1 divided by the new power times the differentiation of the inside bracket. So the differentiation of ax plus b is going to be a
Okay.
plus c. So for example, if I want to integrate 3x minus a to the power of 5, the integration of 3x minus a to the power of 5 is going to be 3x minus a to the power of 5 plus 1, 6, divided by the new power 6 times the differentiation of the bracket. What is the differentiation of the inside bracket? What is the
3.
differentiation of 3x minus 8? 3, right?
3.
So this is going to be 3 plus c. So as the end result of the integration, you are going to get 3x minus 8 to the power of 6 over 18 plus c. That is the answer. Now you have a scalar number being divided by this bracket that is raised to some power. So to simplify this, you can take this bracket power in the numerator, and that is going to be negative 3. This value of 8 is a scalar number. It can be pulled out of the integration sign, and then you can integrate this. So 4x plus 1 to the power of minus 3 plus 1 is minus 2 divided by the new power times the differentiation of the bracket, that is
4.
4 plus c. So you are going to get minus 1 over 4x plus 1 to the power of 2 plus c.
Okay.
Is this correct?
Yes, sir.
Okay, how do you plan on doing the third part?
You can.
What is the first step?
So you can take it as 12 into, and then 2x minus 7 in a bracket with the power minus 1 upon 2.
That's correct. Then,
And then you can take 12 out and then just integrate it.
yes. So the integration of 2x minus 7 to the power of negative half is going to be negative half plus 1 is half divided by half times the differentiation of 2x minus 7, that is 2 plus c. So the end result comes out to be 12 times 2x minus 7 to the power of half plus c.
Okay.
Let me know when you're done.
Sir, I'm done.
Okay, let's see a word problem. There's a curve whose gradient function is k times 2x minus 3 to the power of 3, where k is a constant. The gradient of the normal to the curve at the point 2 comma 2 is minus 1 over 8. Find the equation of the curve. So first, the gradient of the normal, if the gradient of the normal is minus 1 upon 8, then what is the gradient of the tangent?
For the tangents, oh, so it's gonna be 8 then.
Yes, it's going to be 8. So this is the value of dy by dx, and this value of dy by dx is occurring at the value of x as 2.
Oh,
So
okay.
using this expression dy by dx equals to k times 2x minus 3 to the power of 3, I know that dy by dx is a value of 8, x value is 2, so it is going to be 4 minus 3, that is 1. 1 to the power of 3 is 1. Therefore, the value of k comes out to be 8.
Okay.
Okay, so your gradient function is now going to be 8 times 2x minus 3 to the power of 3. You are being asked to find the equation of the curve. Equation of the curve is going to be obtained by integrating the function.
Okay.
So if you integrate the function, y is going to be equal to 8 times 2x minus 3 to the power of 4 divided by 4 times the differentiation of 2x minus 3, that is 2.
Okay.
What is the one thing that I'm forgetting over here?
You have to add c.
Yes, you have to add c. So the equation is going to turn out to be 2x minus 3 to the power of 4 plus c. To find the value of c, I must have a coordinate. I must have a point on the curve. So the
Yeah.
point given to me in the question is 2 comma 2. So when y is 2, x is 2, this is going to give you the value of c as 1.
Okay.
So if c is 1, therefore the equation is going to be y equals to 2x minus 3 to the power of 4 plus 1. This
Okay.
is our equation of the curve.
Okay.
Do you want to note down anything? Should I wait?
I've already copied it.
All right. Then we have integration of exponential function. Okay, so integration of this exponential function e to the power of x is e to the power of x plus p. In exponential functions are special functions whose integration or differentiation is the same function.
Okay.
If you have an expression that, if you have a exponential function that is raised to some power, for example, e raised to the power of 2x plus 5, then integration of such kinds of exponential function is the function itself divided by the differentiation of the power. So the differentiation of the power is
2.
2.
Okay.
This is the integration. Therefore, the answer to the first part is going to be integration of e to the power of 2x is going to be e to the power of 2x
Upon 2.
upon
Upon 2.
2 plus c.
Yeah.
E to the power of minus 7x is going to be
E to the power minus 7x up, upon minus 7 plus c.
correct. So minus 1 upon 7 e to the power of 7x plus c. Okay, then e to the power of 6x minus 5 divided by 6 plus c.
Okay.
Okay. A curve is such that dy by dx is equal to k times e to the power of 2 minus x plus 4x, where k is a constant. At the point 2 comma 10, the gradient of the curve is 1. Find the value of k. Okay, I'm giving you 2 minutes. Try this out. All right. So let's solve this together again.
Okay.
dy by dx expression was given to us. We were given a point and we were given that the gradient of the curve is 1. This gradient of the curve is actually the value of dy by dx at x equals to 2. So when I'm going to use this expression dy by dx equals to k e to the power of 2 minus x plus 4x, I know that the dy by dx value is 1, x value is 2, so k e to the power of 0 is 1, so k comes out to be 1 minus 8, that is minus 7. This means that dy by dx expression, we are done with the first part. Now for the second part, to find the equation of the curve, we are going to use the gradient function, that is minus 7 e to the power of 2 minus x plus 4x. I'm going to integrate the function to get y. Integration of minus 7 e to the power of 2 minus x is simply going to be minus 7 e to the power of 2 minus x divided by minus 1, because the differentiation of 2 minus x is minus 1,
Yeah.
plus 4 x squared upon 2 plus c. So 7 e to the power of 2 minus x plus 2x squared plus c is equals to y. To find the value of c, do I have the coordinate on the curve?
Yeah.
2 comma 10. So when y is 10, x is 2. This brings us the value of, what is the value of c coming then?
Minus 5.
Minus 5. Good. So therefore, the equation of the curve is going to be y equals to 7 e to the power of 2 minus x plus 2x squared plus, sorry, negative 5.
Yeah.
Okay. Now we have a second derivative in this question. D square y over dx square is 8e to the power of negative 2x. It is given that dy by dx is 2 when x is 0. To find dy by dx, I'll have to integrate d square y over dx square first. So if I integrate the second derivative, I'm going to get the first derivative, 8e to the power of minus 2x upon negative 2 plus c. dy by dx value is 2 when x is 0. By plugging x as 0, what am I going to get? I'm going to get c as 6.
Yeah.
So if c is 6, then dy by dx complete expression is going to come out as minus 4 e to the power of minus 2x plus 6. Now to find the equation of the curve, I'll have to integrate this again. Y equals to minus 4 e to the power of minus 2x upon negative 2 plus 6x plus c. Simplifying this expression is going to result in 2e to the power of minus 2x plus 6x plus c. Now this curve is passing through 1 comma 2 upon e square. So when y is 2 upon e square, x is 1. Therefore, c comes out to be negative 6. So the equation is going to be y equals to 2e to the power of minus 2x plus 6x minus 6.
Okay.
Do you understand this?
Yes.
Okay. When you're done, let me know.
Okay.
Okay, the next thing that we are going to look at is the integration of sine and cosine function. Now, if you remember, differentiation What was the differentiation of sin x?
Cos x.
Cos x, right? Differentiation of sin x was cos x, and differentiation of cos x was minus sin x, right?
Yeah. Yeah.
So integration is the reverse process of differentiation. That is why integration, if I am going to integrate this cos x, I'm going to get sin x. That's why
Okay.
integration of cos x is sin x plus c. And if I know that the differentiation of cos x was minus sin x. So if I integrate this, okay,
Okay.
if I just integrate this cos x, the integration, the integration of sin x is going to come out as negative cos x. If I just take this negative sign on the other side, integration of sin x is going to result in negative cos x. That's
Okay.
why these are the two fundamental integration of tricks that we are going to use.
Okay.
Integration of cos x is sin x plus c, and integration of sin x is cos x. So extending this concept, if you have cos of ax plus b, if you have cos of ax plus b, then you need to understand that the integration of cos is going to be sine. So if the function was cos ax plus b, the integration is going to be sine ax plus b divided by the differentiation of the angle. This angle, this ax plus b represents the angle over here. So sine ax plus b upon a plus c. Similarly, integration of sine ax plus b is going to be cos minus cos ax plus b divided by the integration differentiation of the angle, that is a in this case.
Okay.
Also remember that whenever we are differentiating or integrating, it is important to remember that the formula for differentiating and integrating these trig functions only apply when x is measured in radians. So this angle should be in radians always.
Okay.
Okay, let's see the first example. Integration of sine 2x. So first of all, identify what is going to be the integration of the trig function sine.
Minus cos 2x upon 2.
Yes, minus cos 2x upon the differentiation of the angle, that is 2, plus c. Still, it
Yeah.
is an indefinite integration,
Okay.
indefinite integral. Integration of cos 5x. So, integration of cos 5x is sine 5x upon 5 plus c. Do you get it?
Yeah, sir.
Now, what do you think the integration of 3 sine x upon 2 dx is going to be?
Um. So it's gonna be minus 3 cos. Sorry, minus 3 upon 2 cos x upon 2.
Okay, so 3 is a scalar number. I'm going to take it out. Integration of sine is negative cos, angle is x upon 2, divided by the differentiation of the angle, that is 1 upon 2 plus c. Okay,
Okay.
so this is going to result in minus 6 cos x upon 2 plus c.
Okay.
Any questions so far?
No, sir, I got it.
Okay, try these questions now.
Okay.
So integration of 3 cos 2x comes out to be
3
3,
sine 2x upon 2.
yes, 3 sine 2x upon 2 plus 5 minus cos 3x upon 3 plus c.
Yeah.
So 3 upon 2 sine 2x minus 5 over 3 cos 3x plus c. Are you done with the second part as well?
Yeah, sir, I'm done with that.
So integration of this is going to be x cube upon 3 plus 2 integration of cos is sine 5x minus 1 divided by the differentiation of the angle 5
Yeah.
plus c. Okay, try this one now.
Okay.
All right. So if dy by dx is 1 minus 4 cos 2x, integration is going to be 1 integration of 1 is x, integration of 4 cos 2x is 4 sine 2x upon 2 plus c. To find the value of c, we are going to use this coordinate. When
Yeah.
y is 1, x is pi by 4. Please convert your calculator in radian mode before solving this. Sine pi by 2 is 1. So the value of c comes out to be 3 minus pi by
Yeah.
4. That is 12 minus pi by 4. So equation is y equals to x minus 2 sine 2x plus 12 minus pi by 4. Is this correct?
Yes, sir.
Should I move on?
Yes, sir. You can move on.
Okay. Then there's a point pi upon 2 comma 5. It is lying on the curve that has a gradient function as 4 sine 2x minus pi by 2. We need to find the equation of the curve. Is the first step correct?
Yes, sir.
So minus 2 cos 2x minus pi by 2 plus 3. The point is 5 upon 2 comma 5. Cos of pi by 2 is 0. Therefore, c is 5. If c is 5, then the equation becomes y equals to minus 2 cos 2x minus pi by 2 plus 5.
Okay.
Then the next part says find the equation of the normal to the curve at the point where x is pi by 3. We need to find the equation of the normal to the curve. We do have the expression for dy by dx. So you can, by plugging x as pi by 3, you in this gradient function, you can find the gradient of the tangent first. So gradient of the tangent is going to be 4 sine 2 times pi by 3 minus pi by 2. What is the value of the gradient coming out?
Sir, I don't have my calculator on me actually right now because my brother needed it.
All right. So
That's why.
if you solve this, 4 times sine of 2 pi upon 3 minus pi by 2. Just a second, I'm going to solve it right now. 2 pi upon 3 minus pi upon 2 is pi upon 6, and sine pi by 6 is going to be 1 upon 2. So 4 times 1 upon 2 is going to be 2. So if the
Okay.
gradient of the tangent is 2, therefore the gradient of the normal is going to be
Minus.
minus 1 upon 2. Also, we need to identify the point when x is, we have the equation of the curve, right? So
Yeah.
when x is pi by 3, what is y equal to? So I'm going to plug in, when you are going to plug in x as pi by 3 in this equation, you're going
Yeah.
to get y as 5 minus root 3
Okay.
after plugging the value of x in this. So this is the point, this is the normal gradient. To find the equation of the normal, you just use y minus y1 equals to m times x minus x1. So this is, if then you can simplify this, y equals to minus x upon 2 plus pi upon 6 plus 5 minus root 3.
Okay.
So that is the equation of the tangent.
Okay.
Okay.
Yeah.
So that is all for today. I'll see you
Okay.
inshallah in the next class now.
Okay, sir.
Okay. Take care. Allah Hafiz.
Thank you, sir. Allah Hafiz.